As we look at this series, we see that we have an alternating series, and to run the alternating series test, we would need not the alternating part, but the rest of it. So let's look at the rest of that. To be positive, well, we actually start here at 5, so it is positive. If we had started lower, it wouldn't be on those first terms, but we do have that condition, and so if we take the limit as n goes to infinity, fixed numerator, denominator becoming larger and larger, this goes to 0. So by the alternating series test, this series converges. So by the alternating series test, we have convergence. Now, let's actually, while we're on this one, because it is an alternating series, talk about, is this convergence absolute convergence or conditional convergence? And we can talk about that with this one. And so what we want to do is we want to look at the convergence of the series that is the absolute value of this. So basically we will leave off the -1. The 5 is positive, and then we know that this denominator is positive for 5 and greater. So let's look at a comparison. If we had square root of n minus 2, that's going to be less than square root of n. So if we did reciprocals, 1 over square root of n minus 2 is going to be greater than 1 over square root of n. And then we could multiply both sides by 5. Now our comparison series here is divergent because it is a p-series with p less than 1. And all of these terms are less than these terms, and the lesser one diverges, so we know that this one also diverges. So since the absolute value of this series diverges, but the alternating series converges, the kind of convergence we had here is called conditional convergence.